Welcome back. We continue our discussion on building a customer behavior model, customer's navigational behavior model, and we thought it as a Markov process and we are proceeding. So, now let us have a look at what are the properties of this transition probability matrix. After you make this transition probabilities, you calculate this transition probabilities, you can now represent it in the form of a matrix. Here of course, you will have entry state, you have exit state and you have other states. Okay. Similarly, here you have entry, exit and other states, and the transition probability values that you calculated now can enter here. So, this is my transition probability matrix. This is my transition probability matrix. So, in this transition probability matrix, my first state is the entry state and my nth state, last state, let us call it from S2 onwards, so that it becomes consistent. This is the S1 and this is my Sn. Okay. Now, the properties, if you look at the properties says from ith state, I is any other state, you have 2 to total n minus 1 number of other states, is 2 to n minus 1 number of other states. So, this one first property tells that from state I, the probability of going from state I, that is any other state, to the first state, that is the entry state, is 0. Of course, it is true, because this is a dummy state and you have assumed that all the visitors entering into the site, before entering into your site, stay in this particular state. So, therefore, from any other state you cannot go to entry state. So, from any other state, this is your matrix P, I1 going to entry state from any other state is 0, going from S2 to entry is 0, this is 0 and so on. And so on. So, now going from a first state to the last state, from entry to exit, nobody, because in the model people will be visiting some of the at least one state before entering to the exit state, otherwise he is not your customer. So, therefore, going from the first state, that is entry state, to the nth state, that is exit state, is 0. No transition can be made from here to here, this is not possible. No transition can be made. If you assume there is a transition from here, then he is not your customer, he is not entering into your site. So, therefore, this is 0. Then coming from, we are considering a model in which return of the visitors is not possible. We are not considering that, we are assuming that we are not considering returning visitors. Look, we are doing a model and we are defining our model assumptions. You can even extend this model to consider re-entry of the visitors if we have the additional data source from a cookie, where the past visit details might also be might also be captured. So, but anyway, we are limiting ourselves to access log only. So, therefore, we do not have any knowledge that somebody is revisiting a specific page. So, therefore, going from page n, that is exit state, from exit state to j, that is any other state, is not possible. So, going from exit state to any other state is not possible. So, all these values are also 0. Now, this is after all a transition probability matrix of a Markov process. So, sum of all these need to be 1. Okay. Now, from entry state there will be some values everywhere, but from exit state all these values are 0. From exit state you are going nowhere. So, we can assume that from exit state somebody can come back to entry state, though we are not capturing this detail. We are simply assuming that customer always returns to the site. Okay. And here from whatever, because to make it this sum 1 possible, whatever values you have here you add it up and make entry to entry as 0, and that all of them will be added up to 0, because after all we are taking all these values and dividing this by this total number of visits, from all the states. Let us go back, here it is not clear. Here we are dividing it by this total number of visits out of this particular state. So, it is always going to be 1. So, you do not have to worry about it. Okay. So, your now this is the property of a customer behavior model graph. When we, and this customer behavior model graph is nothing but a state transition details of the Markov, corresponding Markov chain. Now, I have assumed so far that you do not have any background here, and I have tried explaining in a very lucid manner what exactly we mean by state transition, how to capture it, how to capture think time, and so on. We made 2 matrices so far. One is the transition probability matrix, another is the time matrix, where the total time in the here in the graph, this total time T1 to T300 for this particular page, for this particular transition, we took the sum of all this and divided by this 300. So, that is how we got the time, and we can have a time matrix. This is a transition matrix. Similarly, we can have a time matrix. In that time matrix again you will have this entry, exit and all other states, and everywhere you can have the time, average time spent. Okay. Assuming that these matrices are ready and we are using this Markov process theory, which we have not discussed here, but at this theory at the end suggests few statistics that can be derived from the model. So, the formulas of that we will be now directly using and we will be trying to interpret it. So, we have the mean holding time matrix. This time matrix we are calling as holding time matrix, where the mean values of this time is represented, mean value of this time is represented. So, here you have this Z11, Z12, Z13 and so on. So, these are these small z values and this is your matrix capital Z. So, your mean holding time matrix is this one. Mean time, the average time, the mean time spent in a state, how much time is spent on a specific state, on a specific page, now can be computed from this model. So, this is basically your Z I bar the average time, the mean time spent in a state I is equal to sum of j equal to 1 to n plus 1 first state to the up to the exit state. In fact, the first the exit state we have last one we have considered exit state to be the nth state probably. Yes, we have considered exit state to be nth state. So, therefore, please consider this as n instead of n plus 1. In the slide I will be making it n modification. Right now I am not able to make it because equation editor is not installed here. So, this is the expected time. Please consider this is from your starting state till the exit state. Now, this is how much mean time spent typical visitor spent on a particular state I. Now, we have another statistics called limiting state probability, which is the probability of whether what is the probability that a customer will visit a specific state. So, this will be calculated by raising this transition probability matrix to some very large value. So, if you raise the power of this matrix to a very high value, here of course, we write r tends to infinity, but actually depending on the matrix with not infinity number of transitions will be actually required. This is a theoretically this is something described this way, but if you keep on increasing r value, at some point of time you will see that this matrix p to the power r is becoming stable. There is no change is happening to this particular matrix. So, that will give you the probability of customer individual entries will give you. Now, see what will happen if you make p to the power r, after some point of time all the rows will be same. So, any entry will give you. So, whatever will be this entry will be same, this entry will be same and so on. So, at this point this one will give you the probability of visiting, let us say this is state I, this is the probability of visiting state I. So, this is what is p to the power r. Then mean number of transitions in the process. This can be calculated using this formula, where this nu bar is a set of row vectors with nu I indicates the mean number of transitions from state I to other transient states. Transient states are the one from which if some visitor enters the state, he is definitely go out of the state. This capital I is the identity matrix and p dash is the portion of the transition probability matrix after deleting the row and column associated with the trapping state. The trapping state is the one from which once the user enters can never come out. So, here in this case the trapping state is actually your exit state. So, once this nu bar vector is known, the mean number of transitions in the process, these row vectors are known, then average session length will be j equal to 1 to n plus 1, where n plus 1 is the last state. Please do not get confused, because in the first slide I have made the nth state to be the last state, but here in the slides which will be given to you, it will be this modification will be made. So, n plus 1th state, which is the last state, if you add up all these new bar values from starting from your entry state to all other state, that will give you the average session length. So, once you know the average session length, you can find out the mean time spent in the process, that is mean time spent in the website. So, that this mean time spent in the website in a particular session, that we can say as the session length, is tau I, which is sum of the time. This is this value we have already found out. This is the time spent on each of the pages, the average time spent on each of the pages, and if you multiply it with this nu j I, the number of transitions, average of number of transitions from state I, previous state to the state j, then this is the time spent. So, there is again one more inconsistency in the symbol. So, here I consider this mean time as z I, and here in this slide I will be making the corrections. This is t j bar. So, the mean holding time, this z I, please consider synonymous as z j as t j here, and also another thing, the transition, the last transition was I called as n as the exit state, but this formula n plus 1 I call as the exit state. Please note these two changes here. Okay. So, now let us see one application. The first example, we assume that in this particular website there are some 5 states: home, product catalog search, shopping cart, select and pay. These are the this can be individual web pages or this can be group of web pages under this common theme. Now, entry and exit state have their usual meaning. This is your first and this is your 7th. So, there are total 7 states in this particular example. So, and what will be the size of your transition probability matrix? It will be a 7 cross 7 matrix. And what will be the size of your average time matrix? That is again a 7 cross 7 matrix. So, now consider the following graph corresponding to user's navigational pattern in a site. Each node represent a state consisting of one or more pages. Entry and exit are 2 dummy states. These dangling links, these are I call as dangling links. I did not connect it to the exit state, but actually it would have made this graph look little more not readable. So, just to increase the readability, these are just left free, but please assume that these links which are not connected to any state are actually connected to the exit state, which means the user can go out of this state. Okay. The number associated with each branch correspond to the transition count. So, transition counts are here from state 2 to state 3, transition count is 20. From state 3 to state 4, transition count is again 20 and so on. And from entry, let us say total 75 entries have been made to the home state and 25 links are made to the product catalog state. The numbers associated with each of the branch correspond to the transition count. This is the transition count and this is the accumulated think time in second, accumulated think time. So, to find out the average think time, you have to divide it with this number, this frequency number. Okay. So, now we can compute this. I expect all of you to compute these things, and when we give you the questions, we will be giving the questions. So, before attempting to solve the problems that will be given to you, this particular example problem, you do it yourself, and if you have any doubt, please ask. So, the transition probability, so you can compute the following transition probability matrix, you can compute the mean holding time matrix. Then after you compute these two, then you can find out the mean time spent in a state. This is the mean time spent, this is the mean time spent, okay, it is possible. So, this is the mean time spent in this state. So, the mean time spent in this state can be found out from this formula, and once you find out the mean time spent in the state, you can find out the average session length. Now, how can you find out the average session length? Average session length is this one. Okay. So, here also let me make one more correction. Let me make one correction, so that the corrections are, you are no more confused on this, because we have assumed from the beginning there are total n number of states, and here also we have assumed that there are total n number of states, and here also we assume that there are total n number of state. And what is this nth state? Nth state is the exit state. Okay. So, now the slides are corrected here itself. So, you do not have to worry about it anymore. So, the average session length can be found out from this formula. Look, doing this preliminary calculations, these calculations are quite primitive, because this what is complicated here is finding this formula. We are not going to talk about how to get this formula, because this thing is already available in any textbook. Follow, let us say, Hillier-Lieberman on stochastic processes, and this formula you can find out from there itself, or any other standard textbook. So, after you find out the session length, the question asks average time spent per session. So, average time spent per session can be found out from here. This is the average time spent in the process, which means in the entire session. For your convenient, because session is something in which the user is responsible for for being within the site. So, this is the average time spent in the session. Then migration rate from state shopping cart. Now, what is the migration rate from shopping cart? Look, this is your shopping cart. How many people went out of the site from the shopping cart, which means they have put their product in the shopping cart, but they did not come to pay state. They actually straightway exited from the site, which means they did not ultimately buy the product. Okay. So, how many such people? Maybe many people are, this can be interpreted in this way, maybe many people are coming, they are selecting the product and they are keeping it in the shopping cart, they are knowing the total price, etc., but while buying the product they are not buying it from your online store, they are going to maybe a physical store to buy it. So, what is that migration rate? what is the rate at which the people are living from this particular state. That also you try to find. What is your buy to visit ratio? So, how many people came to the site, and out of that how many people actually come to the payment state. This is your payment state, this is where this is finally people who have made payments, which means they have made the purchase. The how many people entered into the site? Let us say total 75 plus 2500 transactions were made to the site. Out of that, how many people actually completed this pay process and left the site? It is only 9. So, this is your buy to visit ratio. Now, so far we have considered that entire access log can be thought of as taking it as a whole, we have calculated the customer behavior. However, to make it more refined, this process, we can now cluster the center. We can use for clustering the center, we can use any standard clustering algorithms like k-means etc. And after clustering the sessions, for each cluster we can think of understanding the customer behavior. That can give few more insights. For example, consider this second example. Here the site contains 5 states: browse product, search product, select product, add to cart and pay. And some 5 we did not discuss any clustering algorithm, but sessions can be clustered, just assume this. Now, this is your first cluster, second, third, fourth and fifth. You made 6 clusters. Look, the cluster types can be understood from these values that you have calculated. For example, look, buy to visit ratio for the first cluster is much more higher than that of the 6th cluster, which means more in this cluster more number of people actually bought. To explore it further, look here, total number of sessions devoted for this cluster is this many, and total number of clusters devoted for total number of sessions devoted for this cluster is 1.5, which indicates more sessions in people in this cluster where more number of sessions are devoted, which means more sessions means each session is for captures the history of user for that period. So, this many number of sessions, this many fraction of the sessions, the buy to visit is more, and this number is much higher than this. So, which means more number of people who are coming to the site are interested to buy. It is a good thing that people who are coming to your site is more people are interested to buy from your site. Look at again another interesting phenomena. The session length here is much less than the session length here. These category of people were not in their percent, very few people are of this category. First of all, their buy to visit ratio is very less, and their session length is very high, which means they have continuously browsed through your products. Maybe they are the newcomers who browse a lot and purchase less. Maybe this is a group which you should target. this kind of, if you online environment you can track the properties of this group of visitors, then you can put more online effort like showing advertisements or doing some kind of online activity. In fact, during marketing we are discussing about how to convert a regular visitor finally to your buyer. So, you should be considering if we can actually group and target this customer, we can say we can provide the facilities which will make them more interested, and finally possibly they can become a more aggressive buyer like this group from your site. Now, this is tells you VA how many people have added the products to the cart. VA is the add to cart. Here 11 around this add to cart, this is what is this V? V is the average number of visits. So, average number of visits of this group to product add to cart category is 11, whereas this is 50. So, this group of people will be adding more to the cart, but they are not purchasing, they are adding to the cart, but most of them are actually purchasing. Then what is VB? Here this browsing and product search are very less, because they know where the product is and they straightway coming and buying. Here VB plus VS, which is actually browsing and searching the product, is too high. These are very inexperienced group of people within your site. So, the point that this is just one example where the parameters are assumed to be derived from a customer behavior model graph, which is nothing but a discrete time Markov, which has been modeled as a discrete time Markov process. And after we derive these parameters, the point that is being made here is you can get many business insights from this data. So, the data that we saw in the beginning, that is your access log data, which was looking quite unreadable, now has been through this modeling procedure has been brought to a form, so that many business insights can be derived. Now, what do you do with this business insight is again a matter to be considered, but anyway we are not going into it, but at least we know that so many things can be derived and can give useful insights about your customer behavior. Okay. Thank you very much. Again we continue with this discussion next class.